UML code generators have been around for a couple of decades now, so automatically converting our UML diagrams to code isn't anything new. And now generating structure, so things like classes, methods, and properties, has been pretty easy. But generating the implementation of those classes was a different story. There have been times when a diagram implies an obvious implementation, for example, and we don't want to have to write a behavioral diagram for it just so that its code can be generated. So today I'm wondering whether JetBrains' new Junie AI agent can do better. Can it generate code for both structure and behavior without having to over-specify everything in our UML? So let's jump in. I mentioned in the last video that we can create a file named guidelines.md in this .junie folder, and Junie will do its best to respect those guidelines. So here are the guidelines I set up for this project. First, I've got guidance about whether to put classes in the same file. The second and third bullet points here are instructions to stay faithful to the UML diagrams. And the last three here just tell Junie to include implementation when it's obvious or specified, but not otherwise. The main reason for most of these rules is to narrow Junie's focus, since we don't want it to create code based on any hallucinations. Next, I ask for a test for any behavior that's not simple. We'll see how it does with that. I don't love overspecified UML diagrams, and I don't love overspecified tests. So we'll see if we can apply the Pareto principle to these test classes. And finally, down here, I explain the project structure. I didn't want to clutter up the UML diagram with packages, so we'll see if Junie can just figure it out from what we've got here. My original attempt at getting Junie to generate code from UML was to give it a PNG or a JPEG file of the diagram, but it wasn't able to read them. So instead, I opted for Plant UML, which uses a simple text-based DSL to create the UML diagrams for us. And there's a pretty good IntelliJ plugin for it too. So let's create a new Plant UML file. I'll just name it class diagram and choose the type of class. Let's clear it out, and I will paste in my first few classes. As you can see, the syntax for Plant UML and UML in general is very similar to Kotlin. It actually looks almost like we're writing Kotlin. The two lines down here say that the dog class implements the pet interface and is associated with the dog breed enum class. So let's open up Junie and ask it to generate code from this UML file. And Junie is a little bit slow, so I'm going to speed things up in this video a little bit. Let's take a look at the types that it created. So we've got the pet interface and the dog class, which properly overrides the name and play members. And it added dog breed in the same file below dog, which is what I had asked for in the guidelines file. Now it did assume an obvious implementation here, which I didn't specify, and it's not quite what I wanted, but we can fix that in a minute. Also, we've got no tests, which I'm fine with, since there's not really any behavior here to test yet. Next, I'm going to paste in a second type named cat and declare that it implements the pet interface. And we can just tell Junie to update the code based on the latest UML. And I'm going to turn on Brave mode so I don't have to confirm all of these terminal commands. Well, let's take a look at the result. Looks about like we'd expect. And again, Junie added an implementation for its play function, so let's fix that now. I'm just going to add a note to that field indicating that it should print out a string. And this is a very straightforward implementation note. Let's see if Junie picks up on it. I'm going to shrink this down to compact mode so that we can see more of the UML. And this time I'll tell it what it was that changed. There it goes. It replaced the function body with the instructions from the note. Well, let's do the same thing for the dog class, but I'm going to be a little more cryptic about it. I'm just going to paste in this note here and see how it does with it. So the idea is that the output depends on the value of the dog's breed. Great. Since we've got some actual conditional behavior now, Junie decided it's time to create a test, and looks like Max, Rex, and Buddy are all ready to play. So we've seen that we can generate the structure of these types, and by hinting at the implementation in a note, Junie's been able to figure out what we wanted. Now, there are times when an implementation is obvious to us. So for example, I'm going to create a daycare class that contains a roster of all of the registered pets. And there's a function to register and unregister, and most human developers could figure out that those should add or remove a pet from the roster. I'm also adding a function to check to see if a pet is on the roster. Now, if I were writing this by hand, I would make contains an operator function, which would allow us to use the in keyword with it. So I'm going to just add a note that simply says operator fun, and let's see if Junie figures out what I mean. Easy enough. Okay, let's ask for the code to get updated based on our latest UML. So we got a daycare class, and Junie indeed figured out that register and unregister just add and remove the pet from the roster. It's understood that daycare depends on pet, but I'll add a line down here to clarify that anyway. And just to clean up the diagram a little, I'm going to tell plant UML to group a few of these classes together. That looks better. Next, let's add an enum class that includes all of the activities that a pet can do while at daycare. I added this verb property so that we'll be able to print out what the pet is doing, like playing, eating, or napping. But instead of specifying all of that, I'm just going to give it one example. Let's see if Junie can figure that out. We can see it looks like it's opening all of these other files to make sure that they comply with the UML, and that certainly won't scale well with our project as it grows. So in a moment, we'll be more specific in our request to Junie so that we can just kind of focus it on exactly what it was that changed. It created the activity enum. Looks like it figured out the verb that I wanted for each of these activities. Great. Let's mark this one as done. Now, so far we've seen that Junie can generate Kotlin code from a plant UML diagram, but let's spin things around and see if it can update the UML based on changes that I make to the code. So I'm going to create a package here and create a new class named schedule. And it's just going to include a list of all the activities on the schedule for this daycare session. And I'll ask Junie to update the class diagram. And there we go. It was a simple change that I made, but it did add the class and also created a dependency arrow from schedule to activity. So I'll mark that as done. Now we seem to have lost all of our syntax highlighting after it made that change, so I'm just going to close it and open it again. Yeah, there we go. I'll also move this up here so that we can keep all the arrows grouped together at the bottom. Now, I want schedule not just to contain a list of the activities for the day, but I want it to be iterable itself. So I'm just going to create a new implementation arrow here from schedule to iterable. Let's see if Junie can figure out this one. This is a little more involved because it's going to need to declare that schedule implements iterable. It'll need to figure out the type argument, which should be activity, and it'll need to implement the interface. This time, instead of telling it just to check the UML, I'm going to tell it to update the schedule model in particular, and I'm hoping that that'll be faster since it won't need to check all of the classes. Hey, all right, it figured out the type argument here and created the iterator function. And I suppose it could have just used class delegation, but this is pretty good. Okay, we've got one more class that I'm going to add today, and it's called session. And it represents a single day of daycare where some pets might show up and others might not. And that's why we've got the attendance property and the arrived and departed functions. Hopefully Junie can figure all this out. But before we run this, let's add some remaining associations here. Okay, let's tell Junie that I added something, but not tell it what it was that I added. That doesn't quite look right, so let's tell it specifically what we added. There we go. Looks like it didn't figure out that it should update the attendance, but it did create a session test, and it's just testing that it's not implemented. I should probably tell Junie not to do that. But first, let's ask it to implement the onArrived and onDeparted functions and see if it can figure things out. There we go. And it even figured out that the pet has to already be registered as a member of the daycare in order to attend a session. Session test is being updated. The test pass. All right, that looks good, so let's mark it as done. Now we've seen how Junie is able to take cues from the names of functions and properties and also from notes on the diagram. And that's exactly what I was hoping for. We don't have to implement a sequence diagram for it to figure things out. Still, let's see if it can read a sequence diagram and generate the code for it. I'll create a new plant UML file. It'll be a sequence diagram. And I'm going to name it with the name of the class, an underscore, and the name of the new function. We'll clear this out and add this very simple sequence diagram. Here's what that looks like. We'll just loop over the items on the schedule, and then each pet in attendance will participate in that activity. The note here just says to print out what the pet is doing, but also if the activity is play, then we'll want to call the play function on the pet. I'll also come over to the class diagram and add the name of the function here. Now, I haven't told Junie to associate the sequence diagram with the class diagram. Let's see if it can figure things out based on just the file name alone. Also, this is getting a little hard to read, so let's move it down here. All right, let's go ahead and get Junie to start working on this. It noticed the new diagram. It's checking the related classes. Looks like it added about a dozen lines to session, and now it's adding some tests for it. Let's peek in on it. That looks great. It created run schedule, looping over the scheduled activities, and within that, looping over the pets. Yeah, that looks right. How's the test look? Looks good. The one thing I haven't tried is seeing whether Junie can figure out implied types. So instead of throwing a regular old illegal argument exception when the arriving pet isn't a member of daycare, let's add a note here saying that it throws a not registered exception. And that type doesn't exist. Hopefully Junie will create it and subtype exception. Now, as I've pointed out, when we ask Junie to just update the code from the UML, it does a very thorough review of the diagrams and the code. Let's see if it can use the get diffs to make changes more efficiently. I will add a hint about that here in the prompt, and if that works well, we could probably just add it to the guidelines. Looks like it's not getting output from getDiff for some reason, but seems to have figured out that it's just the session class that was updated anyway. It created a not registered exception and is updating session to use it. It runs into some failing tests, exactly what we would expect. There we go. Let's take a look at the result. Looks like it properly put it in the exceptions package and extended exception. I probably would have passed in the pet object in addition to the message, but given that it figured all of this just from a little note on the diagram, I'm pretty happy with that. So there we go. That actually worked really well. Instead of telling Junie everything that I wanted up front and just letting it figure out all of the code, with this approach, I'm assuming a lot more control. So developers aren't paid to type code, they're paid to figure out what code should be typed. Even though AI is becoming good at understanding English, I think English just isn't that great of a language for communicating specifications. UML, on the other hand, is a language that's designed to communicate these kinds of things very well. So by combining UML with English, so in other words, by adding notes to our UML diagrams with a simple description of behavior that we want, we're able to prompt our AI agents with a lot more precision. The developer does what the developer does best, and the agent handles the less glamorous part, which is typing in what has already been decided. So if you're on a team that values upfront design, and if you're already using at least some UML, this approach might work well for you. I'd love to hear your thoughts about it in the comments section. Also, I'm really excited that we finally got the first proof of the print edition of Kotlin and Illustrated Guide, and we're planning to launch the book later this month. If you'd like to be among the first to know when it's ready, just head over to print.typealias.com, and I'll send you an email with updates as we get closer to launch day. Thanks so much for hanging out with me today, and I'll see you next time.